Hi, my name is Rad Merchant, and I'll be presenting ParsTranslit, truly versatile Tajik-Farsi transliteration. So, as you can see here in this map of modern Iranian languages, the Persian language is spoken across Iran, Afghanistan, and Tajikistan, and was referred to by kind of three different names. So, Persian, Dari, and Tajik, but they all refer to three dialects of the same language, and they are all mutually intelligible with one another. However, in Tajikistan, they use the Tajik script, and in Iran, Afghanistan, they use the Perso-Arabic script. And the result of this is that mutual intelligibility falls to zero in written form, which in turn means that Tajikistan has about 10 million Persian speakers who cannot access the internet or any other type of written media from the rest of the Persian-speaking world, which is about 10 times larger. This can be seen here with this article, which was actually originally written by BBC Tajikistan and was then transliterated or written in another script by the broader BBC News Farsi department. So they have the same wording, but they are mutually intelligible, but they're just written in different scripts. Unfortunately, there are several challenges in doing that. It's not as easy as a one-to-one letter mapping, and that's because in Perso-Arabic or Farsi, the vowels are often unwritten and ambiguous, while the Tajik script is an alphabet and phonetic standard, so everything is written out. This example here shows that with the phrase "I read the book," "Man kitab ro khondam." So this is a very generous example, but if you do one-to-one letter mapping, you end up with something that looks like this. So the Farsi looks very different from the Tajik, and there are vowels missing, and there's different spelling. So on a larger text, obviously, it would be very hard for a Tajik reader, a native speaker, to understand what's actually happening just by doing one-to-one letter mapping. There are also other challenges like the fact that uppercase, lowercase does not exist in Perso-Arabic, and the fact that there are several Farsi letters that just have one equivalent in Tajik. We are, of course, far from the first people to approach this topic. So there have been 6 previous efforts to our knowledge, but they all have one issue at least. So the earlier ones, as you can see in the table here, 3.1, 3.2, and 3.3, they had faced a lack of data. And so they were often unidirectional, so just Tajik to Farsi, which is the easier direction. And they all use different data sets. And because they didn't have direct parallel sentences, they ended up with very indirect metrics that were not very comparable. Similar problems I've seen with the newer wave of model systems here. So 3.4, 3.5, and 3.6, 3.5 being our previous model as well. So you can see that there is more overlap, but people are still using very different data sets. So 3.4 and 3.5 have overlap, but 3.6 uses their own 1,000-year-old or their version of a 1,000-year-old text known as the Shahnama. It's a poetic text. And while that's still very mutually intelligible with the Persian of today, it of course doesn't really help with newer, more modern words 1,000 years later. And even though some of them were bidirectional and they had these shared data sets, one thing we ran into when we were doing our previous model 3.5 was that they still didn't report very comprehensive and comparable metrics. So they were only using blue score, only using character error rate, and it wasn't split at the individual dataset level as well as at the genre or text domain level. And that's where ParsTranslit comes in, because this go around with our new model, ParsTranslit, we've been able to resolve or address all of these issues. So not only are we the first model to use all available datasets, as you can see in the table, number 5, we also produce directly comparable metrics across models and individual datasets, and we look at different text genres as well to see which are more difficult than others. We also contribute to new datasets of our own, so entity names, which have never been evaluated before and have been taken from Wikipedia, as well as a new version of a previously available poetic work. We also include contextual markers, which are seen in Arabic transliteration, which is very important actually because, and it's never been done before, but contextual markers help as the position of a character is very important in Farsi. So beginning of a token or ender of a token. And this is what the data sets that we use look like. And we split them into 4 different kind of genres that we evaluate across as well. So we have poetry, prose, proper names, and a dictionary. And our model training setup is fairly standard as well. We use the FAIR-seek framework with an 80-10-10 split on each data set, and those contextual tokens that I mentioned earlier, which end up looking like this in Tajik and Farsi. And these are the hyperparameters that we use as well. So for our evaluation method, we compared ParsTranslit with our previous bidirectional model, which is a grapheme to phoneme model, which achieved okay results, but they still weren't fully understandable or easy to read. Sedat Kina, who developed a unidirectional model, which had similar results in that direction. And the final one that I mentioned, the bidirectional model that was only trained on the Shahnama dataset, so the 1,000-year-old poetry. We were unable to implement their model due to some issues, so we used the metrics that they report in the paper on that exact same dataset and compare the other three models with that, what they report. So looking at these model results from Farsi to Tajik, we see, at least in comparison to our previous model, DP, we see that we outperform across all genres and across all metrics to a large degree. And we also see some trends that actually hold true in the other direction as well. So you can see here that poetry is easier for our model than prose by a long shot as well. And entity names prove to be the largest challenge, actually. So our model and the other models see that entity names are the hardest across all these metrics. But we do note that the other model, our previous model, which has not seen this type of data before, has a much harder time of it. And of course, as it has seen, for example, the dictionary and a lot of the poetry and prose as well before, those results are also inflated on that end as well. So the difference is actually greater than is shown just by the raw metrics. And the other direction, Tajik to Farsi, we see these same trends. And obviously there's some interesting parts here because we see that the other models are outperforming only in certain genres. And this is where we see kind of two factors we believe come into play. So the train test contamination I mentioned in the last slide, these two models have already seen this data, so those metrics are all inflated to some degree. And we also believe, this is interacting with the fact that Cyrillic to Farsi is proven to be the easier direction for all models. So just looking at the sequence accuracy and at the sequence level evaluation between Tajik to Farsi and Farsi to Tajik, it's clear that this is the easier direction, and so it's likely that the kind of train test contamination bias is amplified here. Now looking at the final model, the Shahnama, we see that ParsTranslit again outperforms their model in the harder direction, Farsi to Tajik, but in the easier direction, we actually perform a tiny bit worse, which despite having more data, which suggests that these performance gains from additional data do end up plateauing at some point, at least in that easier direction. So like I said earlier, these are some of the key trends regarding entity names, difficulties in direction, and again, or something I didn't mention earlier, was that removing whitespace also was proven to improve accuracy in both directions. So all the models kind of got a boost from that to varying degrees. So it's clear that whitespaces are a problem. Our main takeaways at a broader level are that Tajik-Farsi transliteration is clearly not a uniform task. Some genres of text are easier to transliterate than others. And because of this, ParsTransit's performance, as shown by those metrics, proves that it's currently the only available model that is able to handle a wide variety of texts in both directions. So it's the only one that's readily able to produce understandable, if not perfect, transliterations in real-world, everyday contexts. And just for some examples of our model output in the harder direction, we can see here that in the reference, the mistakes are highlighted, and we can see that our output is still quite understandable to native speakers, but the first word, Sundarman, here, which is actually a proper noun, a name, was interpreted as a noun and transliterated incorrectly. And our model also failed to detect this izafe here, which is a Persian grammatical particle. Also see the fact that an valid alternative transliteration for the word and can be vu or va was also penalized. And that leads me into our future work. We'd like to develop task-specific testing methods to stop penalizing these types of valid alternative transliterations, and also measure the model's ability to detect izafe, because izafe detection is actually a big thing within Persian NLP. And yeah, thank you.